Hello, everybody. So what we're going to be looking at today is the practice test 2. And what I'm going to do is just go through all of the problems. I think there's like 17 or something. And we'll just solve them one by one. I'm going to post the link to the Canvas Studio version of this video, but I'm also going to post a regular YouTube link. That's because I think YouTube has more ability to do things like slow down and speed up the video. So maybe that will be helpful to somebody. Um, but yeah, so I'm just going to go through and I'm just going to solve all of these problems. Before we do that, let's just keep in mind some of the information that I put here. So let's see, the exam is going to be open basically Friday to Monday. That's the real exam, not this. The real exam will be about 10 questions. This is longer than that for extra practice. On the real test, you get 2 attempts. So you can do it once, see what you scored, and then try it again. And the last thing is by Wednesday next week, you need to turn in your work for the problems. Um, the reason you want to turn in your work is because that's how you'll earn partial credit, right? So think about it. If you miss, if there's 10 questions and you miss all of them, right, you've got 0%. But if you turn in your work, maybe you'll get up to half of those points back. Now, I say up to, but of course, you can earn more than half credit. It's just that half credit is kind of the um, average amount of partial credit people get. So, yeah, just keep that in mind that you want to turn in your work uh, because that's how partial credit is earned. Okay, with that being said, let's just go through these problems here. I think this will be the best way to do it. Yeah. So, question one right here. So, question one says, what is the difference between a relation and a function? So, a relation is a set of ordered pairs, and there's no restriction on those pairs. So, just like it's a set with like an x and a y, x1, y1, and then another x and y, and then another x and y, etc. And there's no restrictions on anything. A function is a relation, but there is a restriction. The restriction is no repeats on the first term. No repeats for the first number in the pair. So you just read the 4 options here, and one of those will be correct. So let's see what the first one says. A function is a set of ordered pairs. Nope. I mean, it is, but if you look at the bottom two, it says like a relation is a set of ordered pairs. A function is a special kind of relation, right? So it's got to be one of these. And this third option says a special kind of relation in which no 2 ordered pairs have the same second coordinate. So the key there is that that one says second coordinate, but the actual one is, accidentally. The trick is that it's the first number that can't be repeated. So it must be this one. A set of ordered pairs, a function, is a special kind of relation in which no 2 ordered pairs have the same first coordinate. So the option is the one that I marked. Right, next one. Number 2. Now, when you look at these problems yourself, the answers should be the same, but the order is not going to be the same, right? So, like, for me, it was like option D. If you go A, B, C, D, was the answer, but it's not going to be D for you, probably, because they do get shuffled. Um, all right. Question 2, also from section 3.1. Notice that I did label these with what section they're from to help you find information. All right, question 2. The number of cubic yards of dirt D needed to cover the garden with an area A square feet is given by D equals G of A. So the key here is knowing this, right? Well, not knowing, but writing this down. D equals G of A. And if you label what the D and the A are, D is, it says, cubic yards of dirt. So dirt, D for dirt. And A is what? We look here, the number of yards, blah, blah, blah. An area, A square feet. So this is an area in square feet, right? So we just read that from the first sentence of this problem, and then we see it says a garden with the area 800 says area equals 8,000 feet squared, and then it says requires 80 cubic yards of dirt, 80 cubic yards. Well, that must be, if area is the 8,000, then the 80 cubic yards, that must be the D, the dirt, right? So all they want you to do is just put the numbers in the right place. So you've got, uh, well, so you've got G of something equals something. And so inside of the G, you put the A. The A is 8,000. And on the other side of the equal sign, you put the D, the cubic yards of dirt. D is 80. So this is what you're looking for. And in the options that we have, um, oh, I labeled these wrong. Oh no. There's typos on these. These all say D of 80,000, like D. That's all these D's are supposed to be G's here. Oh man. Um, well, that's a mistake. So the option should be this one, but that D should be a G. I need to fix that. Um, and also, I should not have put the text there that explains the problem. Um, so that's just a typo. It should be written this way. Um, G of 8,000, not D of 8,000. Uh, Fix that. Question 3. Question 3 from section 3.1 as well. Select all of the following tables which represent y as a function of x. So the key here is actually that definition that we looked at, remember? So function is going to mean no repeat, no repeated x values, right? The first entry in the pair cannot be repeated. So you just look at the x's and see which ones are repeated. So like if we look at A first, you look at the x values, right? Like for A, the x values are -5, 3, 6, 9, and that's it, -5, 3, 6, 9. No repeats, right? No repeats. That implies it is a function. Okay. Um, if you do the same for the others, I don't want to write all the x values down, but if we look at B, the x values are -4, 3, 5, 8. Okay, there's no repeats, no repeated x values. So that means it's a function. C, we have -3, 3, 6, 9. I don't know why I wrote them down this time. Also, I don't know why I put an equals there. But the key is that there's no repeated x values. So it's also a function for the same reason as the others. And D, well, if you look at D, -4, 3, 3, 9, right? There's a repeat there. So there's a repeated x value. 3 is used twice. So that's going to mean that it is not a function. The x values cannot be repeated. So A, B, and C are functions. D is not. All right. Problem 4. Problem 4. Evaluate the function at the requested values. So we're just plugging in numbers here. So the function is f of x equals square root x, and we are supposed to calculate f of 4. So f of 4 is the square root of 4, which is, of course, 2. And the other one is f of 49 over 36, which is the square root of 49 over 36. But you can do a square root like that as the square root of the top over the square root of the bottom. So 7 over 6. So just looking at these, I see that it is this option here. And you have to be careful not to mix it up with the one right above it, which has a 6 over 7 instead. Okay. Again, just another reminder. This was like the third option for me, but it is not necessarily the third option for you. So we got the answers here. That's what you need to look at. Right. Number 5, find the domain and the range of the function. So remember that the domain of a function is going to be the set of all inputs, which is generally going to be the x values, and the range is going to be the set of all outputs, which is generally going to be the y values for the function. So with that in mind, we are just going to look for the domain f, I guess, is going to be the set of all the x values. So you just list them: 8, -8, -4, -1, 32, 32, 43. And the range is just going to be the y values or the f of x values. And again, you don't have to put them in any special order. You just list them. So 63, 52, 34, 85, 10. So which one does that? Looks like this one. Second option. Yeah. Third option has them backwards, and the first option is just wrong. Right. Next one. Find the domain now. Find the domain of f of x equals 1 over 5x minus 2. All right, how do you do that? So the key to this one is to think about what is not allowed. So what is not allowed on a function, so we can leave those points out of the domain. So the domain is all numbers except ones that make a divide by 0 here. So all the numbers except ones that would make a divide by 0. So to find those, what you do is we're just going to set the denominator equal to 0. And then we're going to solve that. So to solve this, we just add 2 to both sides. So we end up with 5x equals positive 2. And then we should divide both sides by 2. Or sorry, divide by 5 actually. So over 5 on the left, over 5 on the right. Cancel, cancel. And what we're left with is x equals 2 over 5. So we end up with x equals 2 over 5. That turned out to be, it's also positive 2 over 5, which matters because some of the questions kind of made a mistake there. Some of the answers made a mistake there. And we get this value. Now, this is not the domain. This is not in the domain because there would be a divide by 0. So this is what is not in the domain. So the way you would say all the numbers except that number is as follows. So we want to say everything except 2/5. So the domain of f is equal to, you go negative infinity, always start with negative infinity, going up to 2 over 5, parentheses leave out the 2 over 5, So this is all the numbers less than 2/5. And then we do a union with 2/5 to infinity. That's positive infinity. And this is going to be all of the numbers greater than 2/5. So this is everything greater than 2/5. This is everything less than 2/5. 2/5 itself is not here and not here, right? That's what the parentheses mean. We're not including that number. So this is everything except 2/5. And that is your domain. Can't have 2/5 because if you did, if you put a 2/5 in for x, you get 1/0, which is not allowed. So you do that, and then you figure out which one of these actually matches up perfectly. It's this one. Now, just be careful. Like this last one here, the numbers kind of look right, but this is not the way we write intervals. Like you don't go from plus infinity on the left to 2/5 on the right. Like that is not correct because you have to go in number line order. So like 2/5 is somewhere, and the idea is that this is this interval, and this is this interval. That should be an arrow, right? And out this way is negative infinity, and out this way is positive infinity. So negative infinity is on the left of 2/5, so you have to have it this way, not this way. Positive infinity is on the right, so it has to be 2/5 up to positive infinity, like this, right? So if you switch the order around like this, you're writing it incorrectly. And so that's what's wrong with the option that I have currently selected. This one, what's wrong is that I wrote negative 2/5, and it wasn't, it was positive 2/5. What's wrong with the first option is you can't plug in negative infinity to infinity because of the divide by zero. So this is the correct option, the one I have selected now. All right, next question. Number 7, find the domain. Another find the domain, but this time with a square root function. So square roots have different issues than the fraction. So find domain of g of x equals 3x minus 12. All right, so in a square root, what we know is that whatever goes inside the square root needs to be greater than or equal to 0 because you're not allowed to square root a negative. So we know what is allowed is any x value that makes the inside of the root non-negative is how I'll say that, right? 0 is okay, but you can't have a negative. So what you do to solve that problem is you set whatever is inside the radical, so 3x minus 12, greater than or equal to 0. If that's greater than or equal to 0, then there are no problems. So that's what you do. And then you have to solve that. These are not going to be super hard to solve. We're trying to solve for x, so we're just going to add 12 to both sides. Of course, it cancels on the left. We have 3x over here, greater than or equal to positive 12. Then we should divide by 3 over 3 over 3, and we get x greater than or equal to 4. X greater than or equal to 4. So that is the domain, because we were looking, in this case, we were looking for what is allowed instead of what is not allowed. In the previous problem, we said all numbers except ones that make a divide by 0. So when we found the 2/5, 2/5 was not in the domain. But this, we said what is allowed. And so what is allowed is anything that makes this positive or 0. So this is what we get for our answer. That's the domain, but we need to list it in interval notation. So greater than 4 is going to be starting at 4 and going up to infinity. And you use a square bracket because we do want to include 4. So include 4 means this, not this. Okay? So you just look for the list for which one matches that. Looks like the first one. And we move on. Number 8. Whoa. Okay, so number 8 is from 3.4. We're doing compositions of functions. Although that's what the section was called, technically these are not compositions. So f of x is 3x plus 2. G of x is 4x squared. And we want part A, f of x plus g of x. Very straightforward. You just f of x plus g of x. So f of x is 3x plus 2 plus, I'll put it in parentheses, plus g of x, which is 4x squared. There it is. B is going to be, looks like f over g. They didn't write it completely vertical like that, but they wrote f over g. And that's going to be f on top, which is 3x plus 2, and 4x squared on the bottom. Now remember that technically what we did when we did this is we would say where the denominator, which in this case is 4x squared, is not allowed to be 0. But if 4x squared is not 0, that also means that x is not 0, right? Because the only way to make x, if 4x squared is 0, then x is 0. So these two are the same condition. So you can write it this way, but you'll notice that I wrote it this way. And then you just pick off the one that matches again. So let's look at the first one. First one looks like the correct f plus g, and but the wrong b, right? The b is wrong there. It's upside down. It's supposed to be 3x squared, sorry, 3x plus 2 on top, because that's f, and this one has it on the bottom. All right, let's look at the next option. On the next option, this one's wrong because if you look at the f plus g, we see that the signs are wrong, right? There's some minus signs, but this did not have any minus signs. So that option's wrong. Well, this one's wrong because there's nothing there. This one's right. This one matches what we have, right? Yeah. And that's it. Next question. Probably we have a real composition now. We do. F of x is 3x plus 1. G of x is 2 over x. And we want f of g of x. Now, what I'll do is this. So first of all, just remember f of g of x like this means f of g of x like that. Okay, so let's actually solve this now. So the way you would solve this, or the way I would solve this, is I start out by writing f of x. F of x is 3x plus 1. Then I say we're trying to get f of g. So let's replace the x with a g, like the letter G. Just literally the letter G. G, like that. Okay? What would that be? Well, it would be the same thing we just wrote, but we are replacing the x with a g. So it looks like this. So this is f of g. And then what I'm going to do is I'm going to now replace the g with the formula for g. And to me, this is the easiest way to do this. So we replace the g with the formula for g. And the formula for g is, right here, 2 over x. So 2 over x plus 1. So this is what we get. You can multiply this. You can multiply this. So the 3 times the 2 will be 6. And it'll be 6 over x plus 1. That's what f of g is. And you can write it as f of g of x now if you want. So again, we're just going to look for the one that matches this. Looks like this one. Again, somehow we got a blank option in there. Don't know how. All right, 6 over x plus 1 looks correct, and all the others are just different wrong things. All right, next one. So next one is from a different section. We're on to 3.5. So this is question 10. So what we have is f of x equals x cubed, and what we want is to move it up by 2 and also 3 units to the right. And so you just have to remember where to put the numbers to make that happen, right? Like um, if you're looking at something like this, like a f of bx minus c plus d, like all the numbers in a different place can do different things. Okay, so in this case, we want to go up by 2. So let me just write this. So how did we say it? Okay, we're saying g of x equals, that's how we're writing it. And how do we do this? So first of all, let's talk about up by 2. So up by 2 would be this. X cubed is the regular function, right? That's f. And then up by 2 would be adding 2 here on the outside. So automatically you're looking for one that has a plus 2 on the end. And so looking at these, you can see it's not the option I just selected because there's a 3 there. It's not the option that I just selected now because there's a negative 2 there. So it's got to be one of these first two. And then the question is, how do we move it to the right by 3? Well, what you do, it's not going to be x cubed. It's going to be x plus or minus something cubed. And if you're moving it to the right, it will be a minus 3. So to the x, you need to subtract 3. So x minus 3. And we have like a table of what to do in your notes, like what all the different options are for left, right, up, down, stretching it vertically, stretching it horizontally, and so on. But yeah, so minus 3 would move that to the right. So we have the correct option. And let's look at the next one. 11. So number 11 is kind of the same thing we just did. Um, it's even a 2 and a 3. It's kind of the same thing we just did, but we're doing it visually. So the key here is that you kind of had to know what the original function looks like. And so if I want to graph this, for example, let's say f of x, no, because they call it f of x there. So let's say like, let's just say y equals absolute value of x. What does that look like? Well, what that looks like is it goes through 0, 0. So let's see what we're doing. Okay, so the normal absolute value function looks like this, and it goes right there through 0, 0. So kind of what you can do is you can just look at the one that's there, and you can look at where the corner is, right? Like on the one that they've got graphed, they've got like a V graphed, right? But where is that corner? That corner looks like it's at -2 for the x value and +3 for the y value, right? So it's clearly been moved. And how far has it been moved? Well, it's gone, if it started here, right, then it moved 2 units that way, and it moved 3 units that way, which is up, right? So basically what you're doing is you're starting with this function, absolute value of x, and if we wanted to move it 2 units to the left, it would be that, right? So it's going to be, left is going to be a +2, just like on the previous one, it was a minus because it was to the right. X minus 3 was to the right. X plus 2 will be to the left. So we have x plus 2, we'll move it 2 to the left. And then up 3 will just be a +3. So we just look for this function on our list. And it is the last option. Again, be careful, look at the signs, right? You have to look at the signs and also where the 2 and the 3 are. They can be reversed. And we're on to the next question. Number 12. All right. Oops. So we got a function f of x equals square root x. And we've got, again, more kind of transformations to apply here. What is the formula of the graph reflected across the y-axis? So reflect across y-axis. And if you look up that, what it will say is that the x should turn into a minus x. That's how you do that. And then it says stretch vertically by a factor of 3. I'm just going to say by 3, but by a factor of 3. And in order to do that, instead of f of x, the way you stretch it vertically, it should be 3f of x. All right? So those are the two operations, and we need to apply them both to this f of x equals square root x. So if we're starting with f of x, well, we're going to call it g of x after we're done. If we're starting with a square root x, then we just need to do both of these things. So in order to reflect it across the y-axis, you change that to a negative x. And in order to stretch it vertically by a factor of 3, you put a 3 outside of the function. If you put the 3 on the inside, then it compresses it horizontally. So vertical was the key there to knowing that the 3 had to go outside the function, outside the f. All right, so this is what we're looking for. Looks like this one. Again, all the others have something wrong with them. The sign's in the wrong place, or the 3 is in the wrong place. Next question. Even and odd. All right. So before we get into this, I'll just summarize the rules for you. So the rules for even and odd, right? So even powers of x are even. Right? So like 3x squared, for example, is even. 3 is an odd number, but we're not looking at the number out front. We're looking at the exponent. So it doesn't matter if there's a number out front. I don't know why I put a square again. Like a fourth power is even, a sixth power is even, etc. Okay. Now, odd powers of x are odd. So that includes x because x is x to the 1, and you can put a number out front. Or, x to the 3, x to the 5. Again, you can have an even number out front because we're not looking at that. We're only looking at the exponent. So 1, 3, 5, etc. Those are odd functions. And the thing that gets people is constants. A constant by itself is even. Okay? So when you look at this, 8 plus 3x to the 5th plus 2x to the 7th, each individual part you should be able to label as even or odd. So the 8 is a constant by itself, so that's even. The next one is an odd power, 3x to the 5th, so that's odd. And this third one, 2x to the 7th, is also odd. Now the thing is that the rule that I didn't write here was this. Odd plus odd is odd. Even plus even is even. But odd plus even is neither. Okay. So whenever you see something like this, an even function that you're adding to an odd function, that tells you that this is not going to be either. So it's neither. It's not odd, not even. Okay, so the answer here is Neither. Again, we got another extra option. It's fine. Next question, number 14. Oh, we're on to inverses now. That's the last topic, right? So it says let f of x be invertible. And then they say if f of 5 equals 3, then f inverse of 3 equals question mark. And so the key here is to remember that the way inverses work is they reverse the x and the y values. Basically, so if this is an x value and this is a y value, then for the inverse, going back the other way, this is the y value from f, and then the question would be, what would the x value be? Well, we already know that if this is 5 comma 3, then it's the same numbers over here, but it would be 3 comma 5, essentially. So this should be a 5. So they're basically just reversed. If f of 5 is 3, f inverse of 3 is 5. Okay. And I kind of I said that in f inverse, you reverse the x and the y. That's why I wrote them in the wrong order here. But then I actually pointed, that's the y value from over here, and this is the x value from over here. So maybe I shouldn't have written this like this. But I think this is still a good way to think about it, right? So compared to how the numbers are for f, they would be reversed for f inverse. So the answer is 5. So you look here and f of 3 is 5. F inverse of 3 is 5. Next question. Oh, find the inverse. All right, so these are algebra. Algebra to find the inverse. And we had a specific set of steps in your notes that we followed. I'm going to follow them here. Okay, so when you're finding an inverse, so 5 over 3x plus 2. So step 1 is going to be to change the name of f of x to y. We want x's and y's. So change f of x to y. That's just a naming convention. So I'm going to write y equals 5 over 3x plus 2. All right. The next thing is we switch all the x's and y's. So switch all x and y. So this and this need to be changed. So we get x instead of y equals 5 over 3y plus 2. So we switched all the x's and all the y's. Trying to decide whether to move over to the right here. I think I will. Oops. After you do that, then what you want to do is solve for y. And this is where the work is. This is where the work is. So how do we solve this for y? Well, when you've got a fraction like this, you want to get rid of the fraction as quick as possible. So the way to do that is to multiply both sides by that denominator, because that will let you cancel those. So you will end up with, what color was I using? This. Okay. Now, it doesn't matter if you multiply out this x right now or not. I'm not going to do it on this one. I'm just going to leave it like this. So if I'm trying to solve for y, what I could do right now is divide both sides by x. That'd be pretty convenient, which will cancel out on the left-hand side and leave you with 3y plus 2 equals 5 over x. Okay, we're still trying to solve for y, so I should get rid of that 2. So subtract 2 from both sides. Cancel, cancel, cancel. We will have 3y equals 5 over x minus 2. And then to solve for y, we should divide both sides by 3. So over 3 over 3. And we end up with, what do we end up with? Y equals 5 over x minus 2 over 3. And so I listed it that way in the answer, by the way. But so that was almost the last step. And then your last step after you solve for y is going to be to rename y to be the name of your inverse, which in this case will be f inverse. So f inverse of x is 5 over x minus 2 over 3. And that's how I wrote it over here. So it's that, looks like the first option is correct. The others are wrong for various reasons. But also, you could see this answer a different way, which we don't like having a fraction in our fraction. And the way to fix it would be to multiply the top by x and then the bottom by x. Because when you distribute that, so multiply everything by x basically, what you would get in that case is 5 over x times x minus 2 times x over 3 times x, everything multiplied by x. But here it cancels. And that's good because then it lets you write your answer this way, 5 minus 2x over 3x. And so that looks a little bit nicer. And so it's possible you would see that answer as an answer in your list instead of the one that we actually selected. So just be aware of that. 14, not. Whoa, hold on. Oh, can't do it because there we go. That's 14, not. That's 15. Oh, wait, that's step. Okay, sorry, I'm dumb. I was thinking that, I'm like, oh, this isn't problem 4, but that's like step 4. Okay, so yeah, so there's different ways to write the answer here. I think we've got the right one. So let's move on and do number 16. Almost done. 16, find the inverse. Another find the inverse of g of x equals 5x plus 12. So this is going to be a lot easier than the previous one. I didn't want to start with the easiest one. So let's do this. Okay, so what's our first step? Our first step is to change the name. So instead of calling it g, we're going to call it y. Y equals 5x plus 12. Okay, then what do? We switch the x's and the y's. So x equals 5y plus 12. And then we need to solve for y. So I have x equals 5y plus 12. This is easy to solve. Minus 12 minus 12. We get x minus 12 equals 5y. And then we should just divide both sides by 5 because we're trying to get y by itself. So over 5, and we have y equals x minus 12 over 5. Almost done. We just need to rename our function again. So you replace y with whatever you want to call the inverse. So since our original function was g, our inverse we'll call g inverse. And it is x minus 12 over 5. So we just look for x minus 12 over 5. Again, all the answers here are the correct numbers, but arranged in different ways. Looks like the right answer ended up in the last spot. Okay, almost done. I think this is going to be it. So question 17 here. Another inverse. Find the inverse of h of x equals x minus 4 to the 3. So again, we're just following the exact same steps that we've done a couple of times now. So what do we do for our first step? We rename that function. It was called h. We're going to call it y. Second step, we switch the x's and the y's. X equals y minus 4 cubed. So we switch them. Next step, we need to solve for y. I'll just rewrite this. Okay, how are we gonna do this? Well, I'm gonna rewrite it again. That's how. Um, to cancel out a cube, we need a cube root, right? Cube root to cancel a cube, and the other way around. So you just throw a cube root on the right side and throw a cube root on the left side. And when you do this, on the left side, you're just going to get cube root x. And on the right side, the point of doing this was that this entire root cancels with this power and leaves you with simply y minus 4. All right. And we're trying to solve for y, so we just have one more step. Add 4 to both sides. And we get cube root x plus 4 equals just y. So we got that. And then finally, what's our last step is we just rename the function to be whatever we want its name to be. So we're not going to call it y, we're going to call it, well, the original was h, so we should call it h inverse, right? So how about, h inverse x is what? It is the cube root of x plus 4. So you just look for that on your list. Of course, it is right here. Okay, so I think we answered the whole quiz. Let's go ahead and submit it. Do I get a score? I got that one right. Got 1 out of 1, 1 out of 1, 1 out of 1, 1. Just trying to make sure I got them all right here. Okay, good. So there you go. Now, just a reminder on the real test. So real test has differences. It's only going to be around 10 questions, not 17. You get 2 tries. And then for each try, I'm going to put a time limit of like 3 hours. 3 hours per try. Now the questions don't change. The questions don't change when you retake the test. The order of the answers might change, right? Like, so if the correct option was like in spot number 2 here, like let's say choice B, in your second try, it might not be choice B anymore. It might be like choice D, but that doesn't matter. The answer itself will be the same. So as long as you take the test and, in your first try, right, make sure you write down all the questions and solve all of them and, make an attempt at it. But of course, you can take time in between the first try and the second try before you come back and take it. So 3 hours per try, I feel like is going to be, plenty generous, right? And it's going to be due Monday next week. But you can submit your work by Wednesday. And that's because the actual online part of the test is due Monday right at 11:59 p.m. So you can't, if you're doing the test Monday night, you can't turn in your work Monday morning, right? So anyway, yeah. Of course, open notes, open book, whatever. Calculator, okay, and so on. You'll notice I didn't use a calculator at all for any of this, and I don't think you will either, but you could. Okay, so I think that's it for now. So I will talk to you guys later. Good luck with whatever studying you do.